This video is going to cover the brain circulation and the layers of the veins and arteries. So let's start with the brain circulation. If you recall, we have the carotids going up the neck, and we had the common carotid here coming up the neck, and remember that's split into the external carotid going to the external part of the skull, but we also had the deep internal carotid branch here going deep into the brain. Also supplying the brain, we have this vertebral artery towards the posterior, and that comes up between the holes or foramina in the cervical vertebrae. Now, we didn't show that one on the flat man because it wasn't there, but that's also comes off either the subclavian or the aortic arch or the brachiocephalic artery, right in that area where the carotid comes off. Also, we have the vertebral coming off. So again, remember that those cervical vertebrae had foramina in their transverse processes, and that's how we identified them as cervical vertebrae. They're the only ones that have the foramina because the foramina is to carry the vertebral artery up to supply oxygen to the posterior of the brain, whereas the common carotid, internal carotid branch, is going to supply blood to the middle and anterior part of the brain. Now let's go inside the skull. All right, we'll take the skull cap off, and now we can see the arterial supply of the brain. This is anterior here, and posterior here. You can see the olfactory bulbs up here for smelling, the nerve trunks there, so we know that's anterior. And we can see the foramen magnum back here in the posterior. All right, so this is where the internal carotid's coming up. We had a carotid foramen we learned with the skull. Internal carotid here, internal carotid here. Now in the back of the brain, you can see the vertebrals here and here. That one's been cut. There and there. And the two vertebrals join at the base of the brain to become the basilar artery. Now that's basilar, not basilic. Basilic we had in the arm. The bottom part of the arm, upper arm, was the basilic. This is basilar. All right, now notice that we supply the anterior part of the brain here. That's the anterior cerebral, this long branch. The middle cerebral here, and the posterior cerebral here. So when the internal carotid comes up, it's going to send a branch to the middle of the brain, the middle cerebral, and it's going to send a branch to the anterior part of the brain, the anterior cerebral. Same on this side. Internal carotid, middle cerebral, anterior cerebral. The basilar is going to supply the posterior cerebrals here and there. So we got the whole brain supplied. But we also need to have another protective mechanism in case one of these arteries gets blocked. We want to be able to supply the brain with an alternate mechanism. So what we have here is these special arteries. This one, then one connecting the two anterior cerebrals. That's called anterior communicating because it's connecting or communicating the two anterior cerebrals. And back here, this branch here, connecting the basilar to the middle, is the posterior communicating artery because it communicates the posterior part to the middle part. Now these communicating arteries complete a circle here, and that's called the Circle of Willis. And it's protective in case a branch gets blocked somewhere. Let's say this branch got blocked. Well, the blood can go around this branch, around the circle, and still supply that area. So notice the Circle of Willis is a connection between all the cerebrals to ensure that the brain gets a good blood supply. Let's follow them again one more time. Vertebrals come up through the foramen magnum and join to become the basilar. The basilar sends a branch off called the posterior cerebral. The basilar sends a branch off here called the posterior communicating. It communicates with the middle cerebral, which comes off the internal carotid, and we also have an anterior cerebral going anteriorly, and their little connection between the anteriors is called the anterior communicating. Let's start from the front. Anterior cerebral, anterior communicating. Continue the anterior cerebral to the middle cerebral. Both of them are coming off the internal carotid. We have the posterior cerebral here to the basilar to the vertebrals. Okay, now let's go to the arteries and veins. Here they are. Now, the middle one is the artery. It's thicker. And we're going to look down on them in a minute. This one on the right is a vein. We know because we have the valves and because it's thinner. This is also a vein without the valves. They're not showing a valve in that. They're showing the outer covering. All right, let's look down on them now. Let's take this over here. And look straight down. Okay, let's do the artery first. So we have the lumen of the artery. There's the blood inside. And then, working from the inside out, we have the tunica intima, just this brown area. Single layer of simple squamous epithelial cells. Tunica intima, also called the endothelium. Then what we're going to have is a middle layer, muscle layer here, called the tunica media. Now it's kind of thick in arteries. Arteries have a lot more pressure in them. So, and we're going to be able to constrict and dilate these. So the tunica media is thick in arteries. And then this outside pinkish layer is the tunica externa, connective tissue for protection and to keep its shape. So tunica intima, tunica media, tunica externa. Now these white areas here are the elastic layers on each side of the tunica media. So this is the inner elastic layer and outer elastic layer. Internal or external elastic. And the elastic is so this muscle can expand and constrict there. Don't disregard this gray area. We're not going to learn that. Tunica intima, internal elastic layer, tunica media, external elastic layer, tunica externa. Now we get over to the, let's look at this vein. We still have the tunica intima, simple squamous epithelium, and that simple epithelium, if it develops flaps, then they are the valves. Valves keep blood from going in one direction. They keep blood going in one direction. All right, now, and if the blood tries to go backwards, you can see these valves will close, the flaps will close. Same mechanism as the flap valves in the heart. Now, here we have a thinner tunica media, and we also have a tunica externa shown in gray this time. Now, they are showing a little elastic layer in the veins, but we're learning that really the elastic layer in the veins is insignificant. They don't need it, and lots of times it's not there, so we'll skip that part. This vein shows the same thing. So basically, if we look at both of these together, both have the tunica intima, except for the veins, the tunica intima might form valves. They both have tunica media, but it's a lot thicker in the arteries. They both have the tunica externa here, probably needs to be stronger in arteries. And then we're going to say only the arteries have the internal and external elastic layers. Okay, that's it for this.